Next, we introduce entropy balance equation for closed systems. Let's recall if the process is reversible, and then the definition of entropy is derivative capital S, which is entropy, is equal to delta Q, heat transfer, over temperature T. What if the process is irreversible, which is more common in this world? What is going to happen to this equation? Still, left-hand side will be derivative capital S. Right-hand side will still be delta Q over T, but we add one more term, delta sigma. Do you remember sigma? Sigma is called entropy production, which we introduced under Clausius inequality. If sigma is equal to 0, that means the system is reversible. If sigma is greater than 0, that means it is irreversible. And if sigma is less than 0, that means your design is impossible. It violates second law. So now if you take a look at our second equation, if the process is reversible, sigma will become 0. So the second term in the right-hand side just goes to 0. And then our second equation just becomes exactly as the first one on top. So the more general equation we should use is always the second one. And if we integrate this equation, what's going to happen? Left-hand side will be delta capital S. And right-hand side, integrate right-hand side, first term is 1 to 2 delta Q over T and integrate over the boundary. And second term will just become in sigma because integral cancels delta, which is equivalent to derivative. Okay, so what does it mean? Left-hand side is delta S, the change of entropy, capital S. And the first term in the right-hand side tells you entropy change coming from heat transfer. And second term in the right-hand side is the entropy change from irreversibility. And sigma has a name, like we said before, it's entropy production. So now left-hand side is the change of entropy. What does right-hand side tell you? Right-hand side tells you the change of entropy has two reasons. The first reason comes from heat transfer, which is the first term in the right-hand side. And the second reason is entropy production, which comes from irreversibility, and that is the second term in the right-hand side. How do we understand this equation? We can use an analogy. Left-hand side delta S, you can think of it as becoming older, the change of your age. And then becoming older has two reasons. That's the two terms in the right-hand side. The first term, we can understand it as your lifestyle. So for example, if you work out regularly, this term will be small or even negative. If you don't work out, if you eat unhealthy food all the time, then the first term in the right-hand side will be positive, which will increase your aging process. That's the first reason why you become old, your lifestyle. And then the second term, sigma, we can understand sigma as your metabolism, getting older. That is just nature. Nobody can reverse this process. Getting older is irreversible, it's inevitable. Even if you live healthily, you still get older. So the second term sigma comes from your metabolism. You just have to get older, no matter what you do. Okay, so this is how you can understand this equation. All right, and then again, just like before, sigma has three possible solutions. If sigma is greater than 0, that means the system is irreversible, getting older, not reversible. If sigma is equal to 0, that means this process is reversible. And if sigma is less than 0, that means the system is impossible. That means your design is wrong because it violates second law of thermodynamics.